chickens, pigs, horses, cows, goat, sheep, rabbits, alpaca. What do all of these creatures have in common? We love them for their poop. But why? In this video, I am taking on the ambitious task of breaking down what makes each and every one of these turds so special, how to use them without killing the plants in your garden, and why manure is one of the best forms of fertility when it comes to natural gardening, if you use it right. Now, fair warning, in case you missed the length of this video before opening it up, this is a deep dive video. I'm gonna answer some big questions that you have, some of which you may have never even known that you had. Like, what is the actual difference between hot and cold manure? Do I need to age my manure before using it? All will be answered. And after watching this video, you are almost guaranteed to walk away with an above average understanding on the intricate dynamics of animal duties and growing foodies. Welcome back to the channel. If you're new here, I'm Taylor, and I help gardeners turn their yards into sustainable and regenerative growing environments. And if you are looking for ways to do that, possibly with the help of a supportive gardening community, you can hit the link in the video description or scan the code on the screen to get into my free natural gardening group, learn alongside other like-minded gardeners, and access valuable gardening resources to help you along your way. But enough dilly-dallying, let's talk animal manures. And we'll get into all of the ways that you can use these manures so that you can safely avoid contaminating your garden or accidentally burning your plants. But speaking of burning, there's a burning question that I had on my mind that is seldom addressed, but answering it is really going to set the stage for some of our later discussion. And that question is, what is manure? I'm almost embarrassed to admit that I don't know if I would have had a full answer for you before preparing for this video, because on the one hand, it seems like a very easy answer. Manure is animal poop or animal waste, or it's the leftover parts of the food that the animal didn't eat or didn't digest. And these are all technically true in one sense, but they're also pretty limited explanations and offer little help when it comes to understanding how they could actually then be helpful for your garden. So let's get this sorted out. First of all, what manure is, first and foremost, depends on two things above all else: what animal it's coming from and what that animal's diet was. And we'll get into the categories of manure in the next section, but to briefly state it here, the length of an animal's digestive tract matters when it comes to coming out the other end. Almost all manure contains some degree of undigested or partially digested organic matter, right? This is the fiber, the cell walls, the starches, anything that the animal's gut didn't or couldn't break down. Manure also contains nitrogen, usually in the form of urea, uric acid, or ammonia. This is one of the main reasons that manure is long used and beloved as an organic fertilizer, because nitrogen is the #1 nutrient in terms of quantity that plants need to grow. Manure also contains gut lining cells, digestive secretions like bile and mucus and enzymes, which sounds gross because we're conditioned, rightly so, to be put off by such things. It keeps us alive. This is why our senses are so useful to our survival. If something is burning your eyes from the scent that it's giving off and it looks slimy, you're going to be less inclined to try to eat it. From an evolutionary perspective, our bodies are repulsed by such things. That said, treated manure is a lot safer than you think when it comes to handling and growing your plants. So we'll be touching on many ways that it can be treated prior to using, and in some cases if it needs to be treated at all. Now, the one thing that we haven't mentioned that makes up a significant portion of the manure, if not by weight, but by impact on your garden, is the microbial makeup. As far as what percentage of the manure itself is actually made up of microbes, it's very low. But microbes are micro, and within a single gram of fresh manure, you've got an estimated 10 billion bacterial cells swimming around, not to mention fungi, protozoa, and beneficial nematodes. If you hear the word nematode, by the way, and you get scared, nematodes are a totally normal part of the soil food web. There are beneficial and pathogenic or parasitic nematodes, same thing with bacteria and fungi. The key is actually in the healthy diet and living conditions portion of the conversation. But the microorganisms in general that you're getting when you use manure in your garden are going to be a critical piece of the equation. To sum up, manure is the combination of residual organic matter, nitrogen, and other essential nutrients, gut cells, digestive secretions, water, and microorganisms. So now that we've got the broad picture of what we've got in any given turd, let's take a look at some specific types of turds. The first one being castings, and the most notable casting in gardening circles comes from worms. So we'll focus mostly on what those are bringing to the table, but other castings that you can use, oftentimes referred to as frass, come from black soldier fly larvae, mealworms, crickets. Insect and worm castings are one of the most approachable types of manure for home gardeners because they can be generated and collected fully indoors. That said, while I still consider worm castings as manure, they really kind of belong in a separate category from other livestock manures. And this is a humongous discussion, so I'm only going to really touch on a few of the things that make worm castings so distinct. But if you'd like to learn more, you can let me know in the comments. The main difference that I can articulate comes down to what exactly the worm castings are bringing to the table. With other livestock, organic matter and plant nutrition are a huge component of their manures, with relatively small amount of microbial activity when compared to worm castings. Worm castings, also called vermicompost, is like a microbial activity bomb with large amounts of humic acids and also, interestingly, the same growth hormones that plants contain themselves, such as auxins, cytokinins, and gibberellins. So when we use worm castings on our plants, especially, we're feeding the biological needs more than the nutritional needs. And this is why aerated worm casting tea has become more and more commonplace and widely used in organic gardening circles. But even using fresh worm leachate can be great for plants, especially for supplying humic and fulvic acids. To make leachate, you just strain water through your castings and collect it out the other side. Make sure to use it quickly because the casting themselves should be an aerobic environment containing super safe to use microbes, but if that leachate sits for a while and it can go anaerobic and start killing off the good stuff that you want and start to favor pathogens that can mess with your plants. For the same reason, make sure if you're using a bubbler to make actively aerated worm tea that you keep the whole brew aerated the whole time. Otherwise, you could be breeding microbes that you don't want. Dissolving the castings in water, feeding the microbes a food source like molasses or kelp or fish hydrolysate, and then keeping the brew aerated is a way of massively multiplying the microbial populations of your castings. Again, specifically the aerobic microorganisms. Then you can use this to water on or spray onto your plants to help them grow faster, stay healthy, and build strong root systems. All that said, you can also just apply worm castings directly to the soil. You can mix them slightly into the top few inches of the soil or spread them out over the soil surface and mulch over the top and use them as a soil inoculant. Then when you water over the top, the water will carry the beneficial compounds downward into the soil where the plant roots can benefit. There's a sort of point of diminishing return for worm castings, so a little goes a pretty long way. And we'll touch on this in the quality control section of the video, but one of the main things that you need to do to maximize worm castings efficacy is keeping them aerobic. To do this, use your nose and your sense of touch. If your castings ever smell putrid or like rotting food, if they're pasty to the touch and clump super easily, consider gently working in some finely shredded carbon-rich material. And this will become a theme for all of our manures, but to keep conditions healthy, we have to learn how to balance the pure manure with other materials that keep it fluffy and aerated. Let's move on to our next broad category of manures, and probably our largest one, hot manures. Now, unlike worm manure, hot manures cannot be used directly on the soil when plants are in the ground or on plants without being treated first. And the reason is that these types of manure contain a high amount of nitrogen, but not just any old nitrogen, water-soluble nitrogen. Hang with me here because I promise this will become very relevant and might even change the entire way that you understand plant and soil nutrition. I'm going to do a quick lesson on nitrogen in its various forms and why it matters for our discussion on manure. There are two broad categories of nitrogen: water-soluble nitrogen and water-insoluble nitrogen. Water-soluble, confusingly, is also referred to as inorganic nitrogen, and water-insoluble is also referred to as, you may have guessed it, organic nitrogen. And the last thing for now on these two types of nitrogen are that water-soluble nitrogen forms contain fairly simple chemical structures, and water-insoluble nitrogen forms contain pretty complex structures. If you think about the term water-soluble, you might intuitively guess that this kind of nitrogen can be dissolved and suspended in water, meaning that if that water moves, the nitrogen moves with it. Insoluble nitrogen, however, is not dissolved in water very easily, and so it largely stays put when the water moves around it. Think about the difference between mixing salt in water and mixing beans in water. The salt will pretty quickly dissolve, and then wherever the water gets poured, so will the salt be poured. With the beans mixed up in water, though, let the water run out and the beans will stay put. Salt is water soluble, beans are like water insoluble. Salt is like an inorganic nitrogen, beans are like an unorganic nitrogen. Now, the reason that any of this matters for a manure conversation is because plants have almost no regulatory ability to stop themselves from eating. And this means that so long as a nutrient like nitrogen is soluble in the water, that the plant is drinking, it's going to be consuming it, whether it needs it or not. So water-soluble nitrogen means nitrogen that the plant is immediately soaking up into its roots. And this is both potentially really helpful and potentially really dangerous for the plant. How so? Well, the first manure here that we'll look at comes from my personal best buddies on the farm, chickens. Chicken manure is generally considered one of the, if not the hottest of the manures in terms of its water-soluble nitrogen content, and this means that if a chicken poops and I come over and scoop it up and make a little slurry out of it and water it into a plant, several horrible things might happen. First, the high amount of salt in the poo is going to quickly start to dehydrate the plant roots. So rather than watering the plant, it will actually draw moisture out from the plant. Then comes the ammonium overload, and this is such a technical process that I'll suffice it to say that the plant will just have far too much nitrogen than it knows what to do with. It's going to damage the cells, it's going to massively acidify the root zone, and it's going to mess with the plant's hormone system. This makes the plant curl its leaves, dry out, yellow, turn brown, it immobilizes calcium. All of this is why we refer to these manures as hot manures in the first place. It's because of the effect that they have on the plant. It makes it look like they got burned. So in short, hot manures like chicken aren't meant to be applied directly to the soil if plants are in the ground, and they aren't meant to be planted into fresh. Other examples of hot manure would be pig, cow, and horse. Now, chickens are what we call monogastric digesters, which simply means that they have one main gut where they break down all of their food. Also in that category are pigs. Pigs, along with chickens, have relatively short, simple digestive tracts. The time the food spends in their guts means that their microbiome is a little bit less complex than, say, cows. They use enzymes rather than microorganisms as their primary mechanism of breaking down food. And so food comes out quickly after consumption. Part of the reason for chickens' high nitrogen content manure is because they poop and pee at the same time in the same packaged delivery, which is why bird poop is so wet initially. Sorry to gross anyone out. This is the entire topic of the video. So when it comes to pigs, their manure is also quite high in water-soluble nitrogen. And this doesn't mean that they can't be used. I use chicken manure extensively, but that high soluble nitrogen content makes chicken and pig manure a hot manure, and it also means something else. And for this one, we'll move on to our next hot manure, which is horse. Now, horse manure is a big-time winner in the world of gardening manures. Horses produce obscene amounts of manure every single day, making them powerhouse producers, which means that it's fairly widely available. This stuff is hot when it comes down, so it's not immediately usable on planted soil. What distinguishes horses from poultry and pork is that they are herbivores, meaning that they are grazing on pasture or in hay alongside other ruminant buddies, cows, goats, and sheep. Now, there's some debate on whether or not goats and sheep produce hot or cold manure, and I honestly haven't used sheep manure enough to fully know from experience, and I've only aged goat manure that I've obtained. We'll touch on those in a sec. What I can say is that all of these manures are going to produce slightly more microbially rich manure than chickens and pigs. And that manure is going to contain larger amounts of insoluble or organic forms of nitrogen. What this also means, though, is that with grazing on pasture or hay comes a new set of potential issues. We'll hit on this in our quality control section of the video. For the time being, all of these manures, potentially with the exception of sheep and goat manure, are manures that need to be aged or composted prior to usage in the garden. Now, I want to pause here briefly to set up our conversation on cold manures, but also to answer some questions that I had and perhaps you have as well, or maybe you didn't even know that you had until now. When it comes to ruminant animals, their digestive system is interesting. Grass-fed cows, for example, will chew the grass, swallow it, and then send it on down to the rumen and reticulum, the first two chambers of its stomach. After the chewed up grass softens a bit, the cow then unswallows it, re-chews it, and then swallows it for realsies. Once that second batch goes down the gullet, it travels into the third chamber, the omasum, which squeezes out the water and then finally gets pumped into the abomasum, where by this point the grass has been fully fermented. It's full of microbes, millions, billions of microbes, which then get obliterated by stomach acid and are consumed for protein, vitamins, and minerals that feed the cow. A lot of the microbes make it out alive though, and downstream of that digestion event, the remaining plant fibers continue to ferment and the material further breaks down until it comes out the cow's butt. Hence, even though you may have heard that cows eat grass and digest microbes, not all of them are gone by the time that they come out. On the flip side of our livestock manures, we've got our cold manures, and these consist most concretely of rabbit, alpaca, and llama. For rabbits, the reason that they produce cold manure is because despite being monogastric, single-stomached, their food gets 2 passes through their digestive tract. That's right, rabbits eat their own poop once. The second time that it comes out, they're not as interested. Now, yet another burning question here is why? Short answer is because they want to get more goodies out of their food. And before you get too weirded out, because I'll admit it's weird, it's also pretty interesting. So as we discussed with our ruminants, it takes some time for them to get anything out of their grass. For rabbits, because they only have one go of it, they never get the chance to consume and digest those microbes. So the first batch that comes out is full of nitrogen locked up in microbe bodies, and then they eat it, gross, and they get to consume the microbial protein and nutrients. But then on round 2, when that remaining organic matter passes by the cecum through the colon, it gets re-inoculated with microbes and exits as such. Now, all this said, rabbit manure actually contains one of the highest concentrations of nitrogen, even higher than chicken manure. But it's locked inside of fiber and microbial residues, which means that it's in an organic or insoluble state. Now, you might be thinking, it sounds like organic nitrogen is useless if the plant can't use it, so something like chicken manure must be a lot better. That's where what we talk about so much on this channel really comes into view. Now, organic nitrogen is nitrogen that the microorganisms get to decide to break down and deliver to plant roots. They become the portion control arbiters who carefully and collaboratively decide how much the plants need at any given time. They obviously can't give the plant something that they don't have access to, but as long as you've got organic nitrogen in your soil and microorganisms there to break the molecules apart, you're actually providing a safer form of nitrogen than something like raw urea or ammonia for our plants who can't help but gulp it down so long as it's in the soil. Another critical factor here as well is actually something that connects rabbits to alpacas and llamas, and that is their urinary habits. Unlike most livestock, rabbits and alpacas and llamas choose to defecate and urinate on separate occasions. And considering urine is where a healthy portion of this soluble nitrogen comes from in many livestock manures, it makes sense that alpaca and llama manure would be lower in soluble nitrogen. For llamas and alpacas specifically, another reason for their high organic nitrogen content manure is that they are simply very efficient digesters. Camelids evolved in the high Andes on very poor, sparse, tough vegetation, and in order to survive, their digestive tracts became extremely effective at extracting nitrogen from their food and recycling it back into their fermentation chambers before immediately excreting it. All of this means is that what with their tendency to isolate their poo-poo from their pee-pee, plus their remarkably efficient digestive ability, the nitrogen that does come out comes locked into a stable organic state that won't burn your plants when directly applied to the soil. It also comes out as drier pellets as opposed to the looser and larger poo of cows and horses. And as gross as it is to think about, that physical structure really matters. Instead of all of the nitrogen becoming available all at once, microbes have to work through the pellet from the outside in, layer by layer, making a sort of slow release capsule by default. And this is where we'll touch on sheep and goats, because these guys pop out a lot of pellets, but they can also provide hot and cold manure depending on where it's collected. If sheep and goats are out dropping their dung in the field where it's then collected and bagged up to be used, it's likely going to be a whole lot colder than if it was mucked out of a barn. And the reason for that is the same reasons for alpaca and llama manure is colder: urine. In the field, sheep and goat manure doesn't get mixed up with their urine in the same way that it does in a stall with bedding. Whereas llamas and alpacas go number 1 and number 2 in deliberately separate areas, sheep and goats don't care as much. So that barn collected goat manure will likely be a lot hotter than the field collected stuff. Now, there is one more animal manure that I have been asked to speak on, but sadly I have not built up a wealth of experience with it yet, and that is Humanure. I know that Humanure has been used for millennia as a source of legitimate fertility. It makes sense. It's very aligned with my personal beliefs on sustainability and using what resources you have available to you. But I have not yet practiced or invested too much time looking into Humanure and the way that it's properly processed. So I'm going to save this topic for a future video when I'm more capable of speaking from a place of authority on the matter. If you're interested in learning more about Humanure and safe ways to process it, I know that there are various rules that people have for themselves. Some people make certain to hot compost it and then let it age for an additional 6 months. Those same people would say that if it doesn't reach high enough temperatures to kill off potential pathogens, It's best to let it age for several years undisturbed. The Humanure Handbook by Joseph Jenkins is a book that I'm aware of, maybe one of the main books on the topic, and it honestly probably needs to be looked at and taken more seriously. So sorry that I can't speak with more experience on the topic. Urine is also a human-based manure adjacent topic and something that can be used quite a bit more safely, especially as nitrogen source to heat up your compost. Urine is not sterile, contrary to long-held beliefs, but when aged or composted, it's pretty safe to be used, especially when it's not being used on veggies and fruits directly. If you'd like to learn a little bit more about Humanure, I'll leave a link in the video description to a Happen Films YouTube video on the topic, and you can check that out. Going back to our livestock manures, let's touch on what you want to be careful about when it comes to any type of animal manure, starting with what I consider the least problematic issue, which is pathogens. E. coli and salmonella are two well-known bacteria that cause severe illness in humans, specifically when consumed, and both of these can be present in most animal manures. However, and this will become yet another theme, when pathogen-infested manures are composted or thoroughly aged, the bacterial imbalances largely get sorted out and stop becoming a risk. The only real concern is fresh usage, which we've already discussed, carries with it its own set of problems. A more notable problem comes from antibiotics fed to the animals. Now, there's plenty of debate across the internet on how antibiotics affect soil health long-term. Antibiotic means anti-life, and in this case, antibiotics fed to livestock are going to specifically affect bacterial and fungal life in a negative way. On a different side of the die, we have things like dewormers, which largely survived the intestinal tract of livestock and come out undecomposed. And take a guess at who in the soil dewormers might affect the most? Worms. So manure that contains antibiotics and or dewormers will likely have negative effects on soil life, both at the microscopic level at bacteria and fungi, but also at earthworm, beetle, insect level, which means that decomposition is going to be a little bit slower. If you're just tossing this kind of manure out on your garden or field to let it age there, it could be all gone by the time that you're ready to plant. But in the meantime, you're potentially damaging your microorganism population while it ages there. I almost guarantee you that there will be people in the comments of this video who say that they've used animal manure with dewormer or antibiotics in it and had no bad effects. Some people might say that you should never even think about touching such material. In my opinion, over time, pathogens, dewormers, and antibiotics all get sort of sorted out through resilient microorganisms who gradually break them down and reestablish healthy microbial cultures. And then the manure can be used with reasonable assurance that the compounds will have degraded. But the main baddie that you gotta watch out for above all others are the persistent herbicides. Now, these are broadleaf herbicides that have been sprayed on the field where animals graze or where livestock feed is grown. And there's a lot of nuance here, so I'll do my best to help you make the best decisions. But the overarching theme here when it comes to persistent herbicides is please be careful. You could literally contaminate your entire garden and ruin the viable growing space for years if you mess this up. So the stakes are pretty high. What you need to watch out for here is if the pastures and or hay fields that the animal's feed is coming from are getting sprayed with aminopyrrolide, clopyrrolide, picorim, and or aminocyclopyrrochlor, or ACP. And I'll leave a list in the video description of the brand names that these chemicals are in. One of the main ones that you may have heard of already is Grazon. You need to ask the farmer where you're getting the manure from, what they spray on their pasture, and what kind of hay they use to feed their animals. And then you need to ask the hay farmers what they spray on their fields. If they use any of these herbicides, just say no thank you. Now, this is more relevant for just random piles of manure that farmers are sort of stacking up and you decide to ask for. If someone is deliberately selling or delivers to farmers and gardeners in your area, they're far more likely to be clean sources of manure. I recently spoke with a farmer about the manure that they were offering to deliver, asking these sorts of questions. And one of the main reasons that I felt safe about getting a load delivered was because they had a long list of organic growers who have gotten manure from them in the past and had no problems. They also told me that they never sprayed their fields with anything and used organic hay. And by the way, this is largely only something that you need to be concerned about when it comes to herbivores, your horses, cows, goats, sheep, because chickens and pigs don't really eat substantial quantities of grass as a part of their diet, typically. Here's where it gets interesting. When it comes to these herbivores, you definitely don't want to even come close to getting your hands on herbicide-contaminated manure. But when herbicides are removed from the equation, guess what gets added back in? Herbs, and more commonly what we would refer to as weeds. Weed seeds, will pass through ungerminated, ready to sprout wherever the manure eventually ends up. Which means that while at least you're not contaminating your garden with weed killer, you might be contaminating your garden with weeds, which is a far lesser evil, but still pretty annoying. Obviously, it's going to depend on the type of weed, but yet another reason to let this stuff age, or better yet, compost it, which it's about time that we got to actually using manure in the garden for this video. There are many ways that it can be used, and I'll be touching on what I consider the 4 most effective treatments of manure so that it can be used as a means of enhancing soil. And the first one is what I've already referred to throughout the video thus far, but that is direct application. Manure can be applied directly to the field or the garden bed. The type of manure and the timing is what's going to matter most here. Cold manures, spread them whenever you like. Hot manures, if you apply them in the fall after plants have all been harvested, it's going to age and decompose all winter long and into the spring before planting, and most likely it should be safe to plant into. You technically still run a risk of burning your plants, and we've potentially had that issue come up where we planted into manure that was spread long before planting time, but was just still a little roasty toasty, and our plants got a little singed. One of the other potential downsides to applying any of the hot manures that we discussed directly to the soil is that since they contain water-soluble nitrogen, you might remember what that means is that the water can kind of wash them away. So if you apply chicken manure straight to the field or to the garden soil, you're going to retain the organic insoluble nitrogen that's locked on other organic matter in the manure, and that will act as a slow-release fertilizer for your plants thanks to the microbes. But when it comes to the urea nitrogen, several things can happen. One, volatilization, which if you're applying chicken manure across open soil and it's a hot day, that urea converts to ammonium, and the ammonium in warm conditions will convert to ammonia, which will then off-gas into the air. On the flip side, if it's cooler and wetter, you'll likely lose a lot of the water-soluble nitrogen before the urea converts to ammonium, or as the ammonium converts to nitrate. That happens when rainfall carries the nitrate down into the soil beyond the depth of your plant's roots. Or if you're on a slope, it can wash off laterally. The moral of the story here is, in my opinion, chicken manure is just best used as a compost ingredient. And this can mean hot or cold compost, and sorry to flip the terminology on you, but hot and cold in this case do refer to temperature, unlike hot and cold manure, which refers to soluble nitrogen content. Chicken manure is best captured and collected by allowing the chickens to drop their bombs into a carbon-rich bedding. And then this is also the case for pigs, by the way. It really helps to dry out the manure and lock it into a more stable form. And when it's allowed to age and decompose, again, those microbes start forming complex chemical structures that can then be later withdrawn from as needed once plants are growing in the garden. Simply aging manure, preferably keeping it aerated, can be a viable way of dealing with the high amounts of soluble nitrogen. Time spent processing the nitrogen allows for the bacteria to consume it, store it, and bring it to rest in their bodies when they die. When the manure is allowed to age for a long time, fungi also start to really enter the scene. I've collected manure from piles that had aged for great lengths of time and found mushrooms growing all across the top of the pile. Fungi get in there and are working on decomposing the tougher remaining fibers left behind by the bacteria. Composting manure is one of the best and most surefire ways of processing the nitrogen contents, killing pathogens, destroying weed seeds, and it gives you a valuable opportunity to take a valuable resource and effectively double its volume. If you combine chicken manure 1-to-1 with dried leaves or straw, wet it down, stack it up, and hot compost it, you're getting twice the volume, and a greater percentage of the nitrogen is retained in an organic form. Feels like a win-win-win to me. I use manure in almost all of my compost piles. I even like to compost cold manures if I have the chance, just to stretch them out a bit further. Again, these manures count as nitrogen-rich material in a compost pile, whether they're technically cold or hot. Rabbit manure, although it doesn't contain much organic nitrogen, contains more total nitrogen than chicken poo. So if you're able to compost, especially your hot manures, much of the water-soluble nitrogen gets converted into insoluble forms, stable forms that won't be lost once applied to your garden soil and won't burn your plants. Nitrogen gets stored inside microbe bodies. It gets used to build humic acid, protein complexes, and in these states we have a much more sustained form of nitrogen that can't be washed away quite so easily. Complex structures like this give the nitrogen a sort of carbon shield that preserves the nitrogen, locks it away, and gradually releases it, sort of like a permanent slow-release nutrient reservoir as microbes break it apart and feed plants. Immensely valuable. Composting manure is a sort of way to capture all of that nitrogen from the manure and keep it secure. Now, compost making properly done is an aerobic fermentation process, meaning that we want the materials in any given compost pile to stay damp, but to have plenty of access to oxygen. Otherwise, anaerobic conditions can set in and start harboring less favorable microorganisms than what we originally intended. And you can check out my video all about solving your compost problems if you want to understand that a bit better. That said, the next way that we can use manure is going to change courses a bit. And that's because we're actually going to head into the anaerobic fermentation department in the world of JADAM. JADAM organic farming is a branch of sorts from Korean natural farming, and the inventor of this framework details in his book a method of putrefying all sorts of materials to make natural liquid fertilizers. Now, these are not anything close to your standard NPK synthetic fertilizers, but they aren't exactly sources of organic nitrogen either. The way that these are made is very simple. You add manure to a bucket, add a handful of leaf mold soil, and then fill up the bucket with water until the manure is fully covered. You can put something on top of the manure to keep it submerged in the water, and then you want to cover this up and let it age. Depending on how long you let it age depends on how strong the brew gets, how longer you can stretch it. The longer it ferments, the more mineralization occurs, and the more the facultative anaerobes will develop their own culture in this solution. This process of anaerobic fermentation results in a pretty water-soluble form of nitrogen inside the brew, which you might be hearing and thinking, okay, I thought we were going for organic nitrogen, but the answer is contextual. What this natural fertilizer allows you to do is create a solution that can be heavily diluted and gradually applied to your plants. Now, when I make JLF with only plant material, I usually say that 1 week old stuff needs to be diluted 1 part fertilizer, 10 parts water. 1 month old JLF gets diluted 1 to 100, and over 6 month old JLF needs to be diluted 1 to 1,000 to be safe. When it comes to manure, I actually prefer being a bit more cautious, and this certainly depends on the type of plant that you're applying it to. But I would say that a good month or two is playing it just barely safe from a pathogen spreading perspective. Anaerobes are not strictly bad for the soil. They're technically anaerobic pockets that exist all throughout the soil, and putrefaction, as Young Sung Cho points out, is a normal process found in nature. But I think it's worth to play it safer with the manure JLF, since you can be brewing up those E. coli, salmonella type bacteria. I also would personally not be applying these things to things like leafy greens and herbs that I'm going to harvest and then serve up raw. Even in extremely diluted amounts, it's not something I'm comfortable with. Well-aged plant-based JLF is a different conversation. The main benefit to making manure JLF is that you get a good source of long-lasting and far-stretching fertilizers, since you're always diluting it substantially. I also will say that I highly recommend applying this kind of fertilizer alongside its companion solution, JADAM microbial solution, which is a different kind of ferment, takes a few days to make rather than weeks, but it really aids in the process of those nutrients in the fertilizer actually being utilized and delivered effectively when applied to plant roots. And those microbes can also help the nitrogen restabilize in the soil in organic forms, given you have a good carbon content in your soil. Without getting too much more in the weeds on this, I want to move on to the last major way that I can recommend for using manure, and possibly one of the best uses. Fresh manure, compost manure, putrefied manure, all of these can ultimately be taken to the next level by being used to charge biochar. Now, biochar is a whole different subject, so you can learn more about it if you would like from our other videos. The purpose of charging charcoal with manure is to help soak up and retain the nutrients and the microorganisms into a highly stable state inside of the porous structure of the char. Raw or uncharged biochar is a pure carbon structure, and so adding soluble nitrogen alongside microbes will help stabilize the nitrogen and fill up the biochar with beneficial compounds. And this can take a little while. I typically recommend just adding charcoal to your compost piles so that it can get charged up in there. But if you have made a manure slurry, you can pour it over a bucket of charcoal and let it soak up the manure for several weeks or longer until the smell dissipates. You can't mix up just dry manure with biochar. It has to be fairly wet, and you have to give it time to sort out who's going where inside the microbe hotel that is charcoal. But after that time, you can pretty safely use this stuff in and on your garden soil. One quick bonus use that many people, myself included, have used manure for is as worm bedding. Here you're sort of getting a 2-for-1, worm casting and livestock manure. Main thing here is to just watch out for those dewormers in the poo, which would obviously harm your worms. Hot temperature manure is also something that you want to watch for, making sure that it's actually cool to the touch before introducing worms to the middle of your manure pile. Otherwise, you're going to be physically burning them. Now, one last thing that I wanted to share in this video is a thing that I have done and currently do, and likely will continue to do. And it's to utilize my chickens to help me break down ruminant animals' manure. This is a strange concept, I know, and might concern you, but I recently got this huge load of cow manure delivered, and there are a few things going on here. Number one, there's a lot of it, probably close to 10 yards worth. And two, it's clumpy, very clumpy, which means that while I can use it as a compost ingredient, I definitely will be drawing from this pile. The manure itself is going to be a little bit more tricky to try to mix into the carbon materials in my pile. So rather than coming in and breaking it all apart by hand or with a shovel or pitchfork, I'm gonna let my chickens tear it apart for me. Now this might sound gross, having chickens pecking and scratching at cow manure, but there are a few reasons why this is not only helpful to me, but also a pretty natural process. In nature, large animals drop their business, and depending on where it falls exactly, flies are gonna be attracted to the poop for the purpose of laying their eggs. Some of these fly larvae will continue to live to see the light of day, but many of them will be pecked straight out of the turd nuggets by wild birds looking for some juicy bug protein. This process is actually replicated by regenerative livestock operations where cows are rotationally grazed on pasture, moved to a new plot, and once the flies have settled in, laying their eggs, chickens are brought in to peck out the flies and shred up the manure, effectively spreading it out across the pasture more evenly. That's sort of what I'm replicating here. Now this manure has already been aged a bit. It's around 8 months old. I've never had chickens get sick from doing this. But another thing that I'm doing is I'm actually adding well-decomposed wood chips to the top of this pile. I've got this huge weedy pile of wood chips, and I want my chickens to pre-mix this stuff for me until I'm ready to age it a little longer and then spread it out over the garden. So the plan is we'll let our chickens tear this apart, mix up the wood chips into the pile, cover it up, let it age until late fall, and then we'll hopefully be ready to spread this manure all across our garden as a really good source of fertility. Again, I'll also be stealing from this pile to use as a nitrogen source in my compost piles. I compost my chicken bedding already, and I need to keep making compost gradually throughout this season so that I can reapply it to the soil as we flip garden beds for our flower production. But by and large, I'm gonna let my chickens pre-process the majority of this material. If you learned something new in this video, if you wanna hear more on anything in particular that I touched on, or if I missed something crucial, let me know in the comments. Don't forget to check out my free gardening community on School. If that's where you're watching this, you'll get priority for me answering your questions. If you enjoyed this video and you're interested in how you can use even more widely available and homemade soil amendments to build your garden, you will want to check out this video next. Thank you for watching, and I'll see you in the next one.